right, so we're going to be starting a new unit today, linear functions and graphs. I know that we've already done a lesson, but that was just on solving equations, which is an important concept that we need to use throughout this entire unit. I do have a checkup posted, and before class, I will upload the answer key so that you can check to see if you're on track with solving equations. If you have any questions, please make sure that you make time to touch base with me because we're going to be using that skill throughout this entire unit. So some topics they're going to be covering in this unit. We're going to be looking at slope. What is slope? How does it relate to rate of change? How can it be expressed? We're going to look at different equation formats. So we're going to look at slope-intercept form, point-slope form, and general form. We're also going to look at how to take an equation and graph it onto a graph. And then we're also going to look at how we can take a graph and calculate the equation or figure out the equation. We will be doing some work with your graphing calculator as well. So again, you need either a T83 or a T84 plus. And if you notice, I have the graphing calculator at the bottom. It's very important that you're able to do all of this work without a calculator. The calculator is just there as a tool to check your work. All right, so I will go over the calculator, but I'm going to put that at the end of the unit. So before we get started, we're going to be doing a lot with graphing, so it's important that you have a background or an understanding of how to plot on a Cartesian plane. So just a quick refresher from probably elementary or junior high. When we write ordered pairs, we always write x first and then y. So if I wanted to plot a point, let's say 2, 4, I would find x as 2 and y is 4. So 2, 4, I'd plot a point at 2, 4, I'd find where x is 2 and where y is 4, and where those 2 points meet is where I plot my dot. So my dot would be 2, 4. If I wanted to plot negative 3, negative 4, negative 3, negative 4 would be down here. If I wanted to plot negative 5, 2, it would be here, negative 5, 2. It's important for you to know that when we're moving along the x-axis, so this is our x-axis here, when we're moving along the x-axis, as we move left to right, left is negative, right is positive. On the y-axis, so this would be our y-axis here, as we move up is positive, down is negative. If I wanted to plot these points here, I'll just erase what I have. So if I wanted to plot a 0, 3, 0 for x, 3, this would be a 0, 3. B would be negative 5, 0. Negative 5, 0 lands right on the x-axis. Negative 1, 2. You see negative 1, 2. And D is 3, negative 5. So find 3 and then down to negative 5. Something else that we're going to be talking about a lot is quadrants. So our Cartesian plane, that's what this grid is. Our Cartesian plane is divided into quadrants. Quadrant 1. I remember quadrant 1 because in elementary, we start off by doing bar graphs. And so the first graphs that you guys learn are all in quadrant 1. And then in junior high, we introduce you to integers. And with the number line, you start looking at negatives. So we start to introduce you to the second part of that top quadrant. So this is quadrant 2. And then quadrant 3, you started dealing with angles. We started dealing with things in circles, 360 degrees. And quadrant 4. Okay, so quadrant 1, 2, 3, and 4. At this point, I'd like you to pause the video. I have a worksheet, a very short worksheet that's included with your workbook. It's posted with this lesson. Pause the video, do those questions, and then come back here to check your answers. All right, so the answers are in the back of your workbook, but they're also posted here, so just take a quick look to see if you're on track and you're understanding plotting points on a Cartesian plane. If you have any questions about plotting points or you're mixing up your x's and y's, again, just come and talk to me and we'll get things figured out. All right, so on to slope. I'm just going to change my window settings here. On to slope. So the first question I have for you, and obviously we can't all join in to answer, but hopefully you're answering from home. Which line is the steepest? So if you're looking at this graph, the question is, which line is the steepest? And after you've given your answers, the next question that I would ask is why? How do you know it's the steepest? How can you be sure? I'm not going to answer you yet. I'm going to move on to the next screen. But we will come back to this one. So when we're talking about steepness, we're actually talking about slope. So the first question is, what is slope? Slope is a measure of the steepness of a line, and the symbol that we use for slope is M. So I want you to take a look at these triangles here. The first one has a rise of 2 units and a run of 4 units, and the slope is 0.5. Please don't mix that up with the length of the line. We're not talking about the length of the line or Pythagorean theorem or anything like that. The next one here, we have a rise of 3 units, a run of 3 units, and a slope of 1. And the last one, we have a rise of 5 units, a run of 1 unit, and a slope of 5. So my question to you is, how is slope calculated? So just take a quick look and see if you can figure out the relationship between the numbers. How the 2 and the 4 is getting me to a 0.5. The 3 and the 3 is getting me to a 1. And the answer is rise over run. So rise divided by run, or the change in our vertical distance divided by the change in our horizontal distance, is the slope. And again, slope is the steepness of the line. So if we go back and take a look at the questions that we had here, and I was asking you which one is the steepest line, I'm guessing that most of you did not pick B. We could take a look at the slope of B. B has a rise of 2 and a run of 6. Well, 2 over 6 is 1/3. I'm thinking others were probably looking at J. J has a rise, 1, 2, 3, 4, 5, over a run of 1. So 5 over 1 is 5. J is definitely steeper than B because 5 is a bigger number than B. Now, if we look at I here, we also have a 1. And 1, 2, 3, 4, 5. So I also has a slope of 5 over 1, which is 5. Pause the video, take a look, and see if you can figure out some of the other slopes on here. So if you initially looked at the slopes and you thought I and J look like the steepest slopes, you would have been correct. So when we're looking at our numbers, we can't say that G is the steepest because 8's bigger than 3. It has to do with the ratio. So when I go 8 divided by 3 on my calculator, and I get 2.7, that's not as steep as 5. So 5 over 1 is a bigger ratio than 8 over 3. Now, a question that you could be asked sometimes might be something like this. If a line has a slope of 0.4, what might the rise and run be? So in other words, what are 2 numbers that divide to give me 0.4? Well, one example might be 4 over 10. Another example might be 2 over 5. Or 8 over 20. Any numbers that have a rise over run that would give me a decimal of 0.4 would be valid answers. Now, it's also important for you to know that slope doesn't have any units. So when I go 3 units divided by 3 units, so 3 units divided by 3 units, that could be 3 meters over 3 meters or 3 kilometers over 3 kilometers, the units cancel out. And so I'm left with just 1. So the steepness of a line, the slope, has no units. All right, so let's take a quick look at the constant slope property. So if I have a line here, so this would represent a roof truss. If I have a line here and I want to find the slope from here to here, I've got 3 by 3. My slope is 1. But maybe I want to take from a different point and calculate my slope. Maybe I'll use a different color here. So I'm going to find this slope. I'm on the same line. My rise is 1, 2, 3, 4, 5, 6. My run is 1, 2, 3, 4, 5, 6. 6 over 6, my slope is 1. What if I want to take the slope of the entire line? 1, 2, 3, 4, 5, 6, 7, 8. By 8, my slope is 1. So no matter where I go on a line, no matter what line I have, as long as I'm on the same line, my slope is the same no matter where I go. Okay? Now if I had a line that went like this slope would be different than this slope. So as long as my line stays one continuous straight line, my slopes are the same. Now it doesn't matter how I do my rise and my run, as long as I'm calculating my rise and calculating my run and then dividing the two. So let's get into some definitions here. So slope, again, is the measure of the steepness of a line. And the slope, the general formula, is rise over run. So an example that we might have, I've got a line here, and my rise is 4, my run is 5, and so my slope would be 4 over 5. Now there's different types of slopes, and you may have noticed that back on the last question that we had. We can have positive slopes, negative slopes, and so on. So I have to tell you a little sad story here. And this story is about Johnny. And poor Johnny has been born with a terrible, terrible disease. And this disease causes Johnny to have to only walk to the right. No matter where he goes, he always has to walk to the right. And so we're going to talk about Johnny and what life is like for him when he encounters these lines. So our little guy Johnny is walking. And again, all he can do is walk to the right. And when Johnny walks on this line and he's walking to the right, he's moving up. So this slope is positive. And when Johnny gets walking on this line, as he walks from left to right, he's going downwards. So this slope is negative. Now when Johnny gets on this line, it's almost like he's on a treadmill. He just keeps going and going and going. His steepness never changes. So this slope is 0. Okay, so 0, positive, negative. So when we're looking at a graph, we're always looking from left to right. So as Johnny walks from left to right, if he moves up, his slope is positive. When Johnny moves from left to right, he moves down, his slope is negative. And when Johnny moves from left to right, if there's no change, the slope is 0. Now, what happens when Johnny encounters that vertical line? Poor Johnny, standing at the top of that line, has to walk to the right. And as he walks to the right, he falls. And he breaks into little itty bitty pieces. So many pieces that we can't define him as a person. Poor little Johnny is undefined. So the slope of a vertical line is undefined. Now why is that? When we have a vertical line, our run is 0. Our rise can be whatever we want. So let's say this rise is 10. Our run is 0. Well, 10 divided by 0 is undefined. Now what about a horizontal line? The run can be whatever we want, so let's make it 10. And the rise is 0. Well, 0 over 10 is 0. So the slope of a horizontal line is 0, and the slope of a vertical line is vertical. Now I know you want to pretend you're Johnny. So pretend you're Johnny, walk up that line, go positive, negative, and I can almost imagine hearing him coming off that vertical line. is he breaks into a million pieces and he's undefined. All right, so some other types of lines, we have parallel lines and perpendicular lines. When we look at parallel lines, you've talked about those before in junior high, parallel lines have the same slope. So all parallel lines will have the same slope. So if I have a slope of 2/3, my parallel slope will be 2/3. If I have a slope of -4/5, my parallel line will be -4/5. If I have a slope of 2, my parallel line will have a slope of 2. If I have a slope of 0, my parallel line will have a slope of 0. Now, perpendicular lines are different. Perpendicular lines have a negative reciprocal. So if you notice, this line here is positive, this line here is negative. So if one is a positive slope, the other is negative. And the reciprocal means we flip the numbers. So if I have a slope of 3/5, the negative reciprocal will be 5/3, but it will be negative. -2 is the same as -2/1. So the negative reciprocal of that, if this one's negative, the other one will be positive, and it'll be 1/2. Now we do have some special cases. The perpendicular to a horizontal line is a vertical line. So if the slope is 0, that means it's horizontal. The perpendicular line is vertical. Think about Johnny, and it's vertical, so undefined. If the slope is undefined, then the perpendicular to that would be a horizontal line, which is 0. So again, slopes of parallel lines are the same, and slopes of perpendicular lines are negative reciprocals. So let's take a look at some examples here. If the slope is 3, the slope of the parallel line, so M parallel, will be 3. The slope of the perpendicular line, remember that 3 is the same as 3/1, so the slope of the perpendicular line will be -1/3. If the slope is -5, then the slope of the parallel line will also be -5. And the slope of the perpendicular line will be +1/5. Slope of 1/2 parallel will also be 1/2. Perpendicular line will be -2/1 or -2. Undefined, the slope of an undefined line, if it's parallel, is also undefined. And if it's perpendicular, will be 0. So this is our special case here. And the last one, if the slope is -3/4, parallel line would also be -3/4. Perpendicular line will be +4/3. Now, what if we're given a picture or a graph and we have to figure out our slope? What I would suggest is you find what I call the crosshairs. So find points that go through nice grid points on your graph. So I know we have some hunters in our class. Think about lining up that deer in the crosshairs. We're essentially going to do the same thing here. We're going to find points that go through that nice crosshair. And so I can find a point here. I can clearly identify what that point is. I can clearly identify what this point is. And I can draw a triangle and find my rise and my run. So my rise here would be 1, 2, 3. And my run here would be 1, 2, 3, 4. So my slope will be rise over run, which is 3/4. Now it's really important that you pay attention to your scale. Sometimes your grids don't always go up by 1. And sometimes the vertical axis will go up by 1 scale and the horizontal axis will go up by a different scale. So it's important that you check your scale before you do the question. For the next one here, I have a point at -2 and I have a point at -5. So I would draw my triangle. My rise is 1, 2, 3, 4, 5. And my run is 2. My slope is 5/2. But is it? If I look, this is a slope with a negative line. So I'm going to say that I'm going down 5 and right 2. So my slope is actually -5/2. So it's important that you pay attention to whether your slope is positive or negative. Question number 3, Johnny's going down to the right. So this is a negative slope. And So my slope is negative 6 over 8, which can be reduced to lowest terms, negative 3 over 4. All right, well, not all graphs are going to be nice to figure out by plotting on a graph, or sometimes we're going to have numbers that are too big to plot on graphs, or sometimes we're not going to have points that are easily identifiable that we can just draw our triangle and do rise over run. Sometimes we need to use something called the slope formula. And so for the slope formula, we're going to use this formula right here, and it's basically our change in y over our change in x, so rise over run, but we're going to use coordinates to do that. So y2 minus y1 over x2 minus x1. And so if we look at this graph here, we have a clearly identifiable point here at 0, 4, and we've got a clearly identifiable point here at 2, 0. So while we could do our slope calculation and go 4 over 2, negative 4 over 2, negative 4 over 2 is negative 2, we can also use the slope formula. So when we have 0, 4 and 2, 0, a good way to not mix up your variables is to label them first. So the first coordinate is going to be x1, y1, and the next one is going to be x2, y2. Now it doesn't matter which coordinate is 1 and which coordinate is 2, as long as x1, y1 are together and x2, y2 are together. So I'm going to take the formula, and I'm going to go y2, which is 0, minus y1, which is 4, all over x2, which is 2, minus x1, which is 0. 0 minus 4 is negative 4, 2 minus 0 is 2, and I get negative 2. So my slope is negative 2. Again, this one, because we had the graph, we were able to check on our own, but we still use the formula. Common mistakes when it comes to doing this formula. One, you can certainly put everything in your calculator in one step, but if you're going to do that, I encourage you to use brackets. So bracket 0 minus 4 divided by bracket 2 minus 2. The other mistake that you're going to likely encounter is dealing with negatives, and that's what we're going to see in the next question here. So it says find the slope of the line through A, negative 3, 6, and B, 5, 2. So the first thing I'm going to do is label my points, x1, y1, x2, y2, and I'm going to use that formula. Slope equals y2 minus y1 all over x2 minus x1. Well, y2 is 2, minus y1 is 6, x2 is 5, minus x1 is a negative 3. So 5 minus negative 3, I'm going to switch that to 5 plus 3. So 2 minus 6 is negative 4, 5 plus 3 is 8, negative 4 over 8 is negative 1/2. So the slope of that line is negative 1/2. If you have graphing paper and they're nice numbers, you can certainly graph it on a piece of paper and check your answers. But we're certainly going to be coming across other questions that get a little bit more detailed than that. Not necessarily detailed, but we might have decimals, we might have large numbers that you won't always be able to graph on your paper. All right, so this is a time again to write down these examples, pause the video, try them on your own, and then come back and check your answers. All right, so checking your answers, we've got your slope formula, m equals y2 minus y1 all over x2 minus x1. Again, you want to make sure that you label your coordinates, x1, y1, x2, y2. If you labeled yours differently, it shouldn't matter because we're going to get to the same answer in the end. And maybe for B, what I'll do is I'll flip my coordinates just to show you that. So y2 is negative 10. So negative 10 minus negative 8 all over negative 2 minus 3. Well, that's negative 10 plus 8 all over negative 2 minus 3. So negative 10 plus 8. Negative 10 plus 8 is negative 2. Negative 2 minus 3 is negative 5. And negative makes a positive, so we've got 2 over 5. Again, if you wanted to put this in your calculator in one step, I'll show you that right here. On your calculator, you can go bracket negative 10 minus negative 8, close your bracket, divided by negative 2 minus 3. And we get 0.4. If I math frac that, I get 2/5. All right, and if we check the next one here, I'll switch my variables. I'll make this x1, y1, and x2, y2. And we'll see what we get. y2 minus y1 all over x2 minus x1. y2 is -1 minus y1 is -4. x2 is -2 minus 5. Now, even as I'm doing this, I'm finding myself having a tendency to want to mix up my numbers. So for me, I always make the first one my x1. I always make the second one x2. And I get in such a habit of doing it in that same pattern that I'm less likely to make mistakes. But you can certainly switch them and it won't make an issue. So I've got -1 plus 4, which is 3. And -2 minus 5 is -7. So I have m equals -3 over 7. And again, you could check that on your calculator. We had -1 plus 4, or you could have done minus -4 divided by -2 minus 5, and math frac, and we get -3 over 7. So the last example, I'll get you guys to do a quick calculation here. You can use your slope formula, or you can calculate using rise over run. So pause your video, try the question, and then come back. Now for me, any opportunity that I have where a graph goes through 0, 0, I'm going to take it because then I have less work to do. So I can calculate using rise over run. My rise would be 4, my run would be 2, 4 over 2 is 2. Or I can use the slope formula. So y2, so 4 minus 0 over 2 minus 0, I'm still going to get 2. All right, that's all I have for you guys today. Tomorrow we're going to look at slope as a rate of change. Your assignment is to work on your 3.1 worksheet. Make sure you've got a good handle of slope, but we're going to get lots more practice with it tomorrow as well. All right, guys, thanks and have a great night.